Japan has committed more than $40 million to a ground combat system designed to do one thing well: disrupt a Chinese landing before it can gain momentum. This unmanned vehicle is built for the terrain that matters most: mountains, forests, and narrow island roads. This makes it a tool for real-world denial, not a political signal. That is why Chinese planners are watching closely. China's warfighting model in the region depends on rapid amphibious movement, tightly coordinated landings, and immediate control of key terrain. Anything that slows that process creates cascading problems. If Chinese forces are compelled to hesitate, disperse, or fight for access routes earlier than planned, the entire operation becomes riskier. Autonomous ground systems give Japan that leverage. These vehicles can remain forward, detect intrusions early, and contest terrain without exposing crews in the opening hours. Their purpose is not decisive victory on their own. It is friction. Every minute they delay a landing gives Japan more time to bring air power, naval forces, and command decisions into play before a beachhead solidifies. This effort is being driven by Japan's Ministry of Defense through the Acquisition, Technology, and Logistics Agency, which focuses on systems that can deploy with real units, not experimental platforms. The logic is straightforward. If Japan can complicate the first phase of a conflict, it changes the entire trajectory. On the other side is the People's Liberation Army, which has invested heavily in unmanned systems but largely optimized them for scale and mass coordination. Japan is not trying to compete on volume. It is targeting a structural weakness. Amphibious assaults live or die on tempo. Even small delays can unravel coordination, expose forces, and force higher-risk decisions. That is why this system matters, and why it is keeping Chinese planners awake at night. Japan's Ministry of Defense has allocated roughly $42 million to accelerate the development of AI-enabled unmanned ground vehicles. And that figure is revealing. This level of funding signals intent. It is too large for a conceptual study and too targeted for a long-term science project. It is operational funding aimed at delivering a fieldable capability within this decade. The objective is a combat-capable unmanned vehicle that can move through complex terrain autonomously and detect and classify threats using onboard sensors, and support infantry units through reconnaissance and potentially direct fire support, all while operating under contested electromagnetic conditions. These systems are not being designed for ideal environments. They are being built specifically for Japan's geography, where autonomy is hardest to achieve and therefore most valuable. Tight roads, dense vegetation, fragmented urban areas, and uneven volcanic ground all complicate navigation and sensor performance. If autonomous systems can function reliably there, their utility elsewhere becomes far more credible. Japanese planners have been explicit about why they are pursuing this path now. Japan cannot outnumber China, and it cannot afford to absorb heavy personnel losses in the opening phase of a conflict, particularly in remote island areas where reinforcement is slow and evacuation is difficult. Then autonomous systems offer a way to offset those constraints by positioning capability forward without immediately committing lives. These vehicles are intended to operate ahead of main forces, patrolling likely landing zones, choke points, and access routes where early contact is most likely. Their mission is not to win decisive battles in isolation. It is to delay, disrupt, and inform. By buying time for aircraft to launch, for naval forces to reposition, and for political leaders to assess escalation options, these systems create strategic breathing room. In modern conflict, that breathing room can determine whether a crisis stabilizes or spirals out of control. It is important to cut through the hype surrounding this system, because much of the public discussion around military AI quickly drifts into science fiction. These are not independent killer robots roaming freely across the battlefield and making life and death decisions on their own. Japan has been explicit and consistent on this point. Human operators remain in the loop for any lethal action. The role of artificial intelligence is confined to navigation, sensor fusion, and threat prioritization, not autonomous authorization to use force. In practical terms, this allows the vehicle to patrol assigned routes without constant human input, interpret large volumes of sensor data faster than a crew could, and highlight potential threats for operators to evaluate rather than replacing human judgment altogether. Operationally, this approach translates into very specific advantages. The vehicle can move without relying on GPS, using onboard mapping and perception systems to navigate complex terrain. It can identify vehicles, personnel, or equipment using a combination of visual and infrared sensors, even in low visibility conditions. Most importantly, it can flag anomalies and potential threats far faster than human reaction times, giving operators more time to decide how to respond. Speed here does not mean automatic violence. It means earlier awareness and better informed decisions under pressure. The ability to function in degraded conditions is what makes this concept viable in a real conflict. Any confrontation involving China would open with intense electronic warfare, GPS disruption, communications interference, and cyber pressure would be immediate and sustained. A system that depends on constant connectivity or pristine signals would fail almost instantly. Then Japan's design philosophy reflects hard lessons from recent conflicts, where platforms built around uninterrupted links proved fragile. By prioritizing autonomy that can degrade gracefully rather than collapse outright, Japan is trading theoretical perfection for battlefield reliability when conditions are at their worst. The real strategic impact of these systems emerges when they are viewed through the lens of Japan's evolving military doctrine. For much of the post-war period, Japan's ground forces trained primarily for static defense, built around fixed positions, clearly defined lines, and the assumption that any major conflict would unfold slowly enough for reinforcement and escalation management. That model is now being replaced by one designed for speed, dispersion, and survivability under constant surveillance and missile threat. The new approach emphasizes small, mobile units operating across multiple islands, linked by sensors and shared data, rather than by physical proximity or massed formations. Unmanned ground vehicles fit naturally into this structure. Instead of concentrating troops and vehicles in predictable locations that invite missile strikes, Japan can disperse autonomous scouts and forward elements across terrain that is difficult to monitor continuously. These systems extend the reach of human units without expanding their physical footprint, thus allowing commanders to build a layered defensive picture that is harder to target and far more resilient. Rather than relying on a single line of defense, Japan can create overlapping zones of detection and delay, forcing an adversary to deal with multiple points of friction at once. From China's perspective, this shift complicates planning at every level. Amphibious operations rely on speed, momentum, and precise coordination. Landing forces must secure ports, airstrips, on and road networks quickly before defenders can organize an effective response. Autonomous systems disrupt that timeline. They provide earlier detection of landings, force attackers to dismount and maneuver cautiously, and trigger defensive responses before a beachhead can stabilize. Because these systems are unmanned, destroying them does not carry the same escalation risk as killing soldiers. That lowers Japan's threshold for forward deployment and persistent presence, allowing it to contest space earlier and more aggressively without immediately raising the political and military stakes. China already fields unmanned ground vehicles, so the concern is not novelty. The concern is purpose. Japan's systems are optimized for defensive denial rather than offensive maneuver. The People's Liberation Army relies on mass, coordination, and fires to overwhelm defenders. Even a limited number of autonomous vehicles can disrupt that model by forcing cautious movement, generating false contacts, and consuming time and attention at critical moments. Time consistently favors the defender, especially one backed by Allied surveillance, air power, and logistics. This is not about robots winning wars on their own. It is about shaping the opening hours of a conflict, when momentum determines whether an operation snowballs or stalls. That is why analysts believe this development has drawn quiet but serious attention in Beijing. So can autonomous combat robots give Japan a meaningful defensive edge against China? The answer is yes, but not in the way popular culture imagines. These systems do not replace soldiers. They reshape the battlefield by providing persistence, early warning, and risk absorption. Japan's $42 million investment is aimed at changing how ground combat begins, not how it ends. There are 3 implications worth remembering. First, Japan is no longer waiting to react after a crisis begins. It is actively redesigning its ground combat approach around autonomy. Second, unmanned systems reduce political and military risk in forward areas, making deterrence more credible rather than more provocative. Third, this forces China into difficult choices, whether that means slowing operations, escalating faster, or investing heavily in counter-autonomy measures. None of those options is cheap or simple. By the early 2030s, Japan's ground forces could operate with robotic screens ahead of human units across key islands in the southwest. That does not guarantee victory, but it raises the cost of aggression and complicates planning. And that, ultimately, is the strategic objective. So here is the real question. In a future East China Sea crisis, do autonomous defenders delay conflict by strengthening deterrence? Or do they accelerate escalation by lowering the threshold for engagement? Drop your prediction in the comments.